Alright folks, thanks for coming. We will now switch to linear equations in two variables. Before we were dealing with linear equations in one variable. Please subscribe to my channel, like and share this video, leave comments or questions under the video. I will get to them as soon as I can. So we've got a couple of things to cover here. This video will be a general introduction to linear equations in two variables. First, I will define what is a linear equation in two variables, right? And then I will give you two good examples of something you're familiar with that will help you to conceptualize what it means to have a linear equation in two variables, okay? So first I would define what it means to have a linear equation in two variables. A linear equation in two variables is an equation that can be written in this form here, okay? And then it says where A, B, C are real numbers, right? And A and B are not both zero. So this form here is called the standard form. They call it the standard form, okay? You can see examples like this: 2x plus 3y equals to 6, x minus 4y equals to 0, 7x plus 20y equals to minus 40. These are in standard form, right? But the thing is, a linear equation in two variables doesn't have to be in standard form. It can be written like this. You see, these are not in standard form. This over here, y equals to 6x plus 3, 3x equals to 3 minus 20y, x equals to 8y plus 4. So notice that the most important thing is that the equation has two variables, y and x. You see there? Before we were dealing with an equation with only one variable, but now the equations must have two variables. So that's what you mean by, that's what we understand by linear equation in two variables. Now note this: a linear equation in two variables is still a straight line, because the word linear has line in it, okay? So it's still a straight line like a linear equation in one variable. And then also note that a solution of a linear equation requires two numbers, one for each variable. In other words, if the equation is contains two variables, x and y, right? When you get the solution, you will have x, a number for x, you have a number for y. Any number, y could be 3, the solution for x could be 2. This is just an example. So this is where the idea, remember we talked about the idea of ordered pair. Usually a solution for a linear equation in two variables comes in ordered pair form. Remember we said that x is written first and then y. So if the solution is at 2 and 3, then you have to write it like 2 and 3 like that. You can't write 3 first. You have to write the value of x first, and then you write the value of y. So this is very, very important to keep in mind, because you have two variables. When you solve the equation, then you have to have two numbers, one for x and one for y. See, so keep that in mind. All right. Also note that the two numbers that serve as the solution of the linear equation, right, must satisfy the linear equation. What does that mean? Well, okay, if you have two numbers, remember we'll have a 3 and 2 and 3 over there. If let's say the equation is 2x plus 6y is equals to 7. If you put those two numbers, those pair of numbers that you find as a solution, let's say this is the solution. If you put it in here, substitute them in here, the value of x and the value of y, they must satisfy the equation. You should be able to have 7 on the other side and 7 on the left side. That's all that is saying, And then listen, every point on the straight line is a solution for the linear equation that straight line represents. And every solution of the linear equation is a point on the straight line. You recall that we talked about that. Let's say you have this Cartesian coordinate, x and y, and this is a line. Of course, this line here has x and y as the variable, right? If we find a solution for this line, right, every point, well, another way to say, every point on the line is a solution. That's all that is saying, right? And the solution for that equation is a point on the line. It must be a point that lines on that line. That's all that is saying. Just keep that in mind. It's going to be useful when we start solving problems, okay? All right. Here is an example. This example should help you to understand some of this concept, okay? Now, see what it says. It says, determine whether each ordered pair is a solution of the linear equation 3y plus x equals to 8. And then there are the other pairs 6, 2, 10, 4, 1, 3, 8, 0, 2, 2, 5, 1. So basically what you do, you know what is an ordered pair, right? Like 6, 2, for example. 6, 2 means x equals to 6 and y equals to 2. So this example will help you to understand these concepts more, okay? So let's do it. So the first ordered pair given is 6, 2, all right? And the equation, of course, given to us is 3y plus x equals to 8, right? That's what is given to us. So basically, like I said, the other pair means x equals to 6, y equals to 2. All you gotta do, just replace those values in the equation. So then it becomes 3 times 2 plus 6, right? Then the equation is equal to 8. That's what we need to determine. If it's equal to 8, then that other pair is a solution of the linear equation. See? So, but we'll simplify the left side. Is let me see, 6 plus 6, right? Is it equal to, is that equal to, the question is that equal to, is it equal to 8? That's the question we need to answer. Is it equal to 8? Then if you simplify the left side, you get 12. 12 is not equal to 8. So then that means the ordered pair 6, 2 is not a solution. Not a solution of 3y plus x equals to 8. You understand that, right? Because this over here, this is false, So make sure you understand that. So that's not a solution. It's not, that point cannot be found. It's not on the line. If you draw the equation, this point here will not be on the line, because all the points on this line are solutions. All the points if you draw this line, because that's a line right there. Okay, so let's do the next one. What is the next one? The next one is 10, 4. You're given 10, 4. That means x equals to 10, y equals to 4, right? And the equation is 3y plus x equals to 8. Okay. Is that a solution? Well, we'll substitute. 3 times 4 plus 10 is 0 equal to 8. What is that? 12 plus 10 is 0 equal to 8. What is that? That's 22. Obviously 22 is not equal to 8, so that thing is false. That means 10 4 is not a solution. Not a solution of the equation, okay? Of the linear equation. It's not a solution. So what is the next one given to us? The next one is 1 3. So we'll try 1 3, which means x equals to 1, y equals to 3. And then we'll substitute those values in this equation, the equation given. Okay, so we'll have, let me see, 3 times 3 plus 1 is equal to 8. Let's simplify. 3 times 3 is 9 plus 1 is equal to 8. Basically, that's all. We said no because this is 10. 10 is not equal to 8. So because that thing is false. So then we'll say 1 3 is not a solution. It's not a solution of the given linear equation, okay? That's all that means. Alright, so what is the next one? The next one is A0. Let's do A0. The next one is given is 8 and 0. And the equation given is what? Let me make sure. 8 and 0. The equation given is 3y. The equation is 3y plus plus x. 3y plus x is equals to 8, right? We'll substitute the value x equals to 8, y equals to 0. We'll get 3 times 0 plus 8 is 0 equal to 8. That's the question. This cancel out, so we'll have 8 is equals to 8. And this is true. Therefore, the ordered pair 8, 0 is a solution. It's a solution. It's a solution. It's a solution of the given equation, okay? A solution of the given linear equation. That's all. So you see what is going on. What is the next one? The next one, we'll go back and find, is 2 2. The next one is 2 2. All right. The next one is 2 2. So we'll have 2 2, order pair 2 2, and we're given 3y plus s equals to 8. This is x equals to 2, y equals to 2. You put it in the given equation. What do you get? You get 3 times 2 plus 2 is equal to 8. That's the question. 3 times 2 is 6 plus 2 is equal to 8. We simplify the left side, we get 8. Yes, it's equals to 8. So this is true. So therefore, order pair 2 2 is a solution. A solution of the linear equation, okay? Linear equation. Okay. So what is the last one given? It's a 5 1. We're gonna check that one too. So just pay attention to what I'm doing, and then you shouldn't have any problem. What is a 5 1? You give him 5 1. Let me make sure. Yeah, 5 1. You give him 5 1, and then you give him that equation there. So we'll have to check. You give him 5 1, and you give him the equation. You give him 5 1, and 3y plus x equals to 8, right? That means x equals to 5, y equals to 1. Always keep that in mind. You substitute, you get 3 times 1 plus 5. Is it equal to 8? We don't know until we simplify the left side. It's 3 plus 5. Is it equal to 8? We don't know. We keep simplifying. Yeah, this is 8. So this is equal to 8. So it's true. So that point, that ordered pair, okay, that ordered pair is a solution. You know, the other pair can be called a point. It's a solution. Because you remember, if you draw the graph, you put, remember the Cartesian coordinate x, y. If you draw the graph, you gotta get a line. So this ordered pair, this thing here is a point. It will be a point somewhere in the line, somewhere. You know, all the points on the line they're all solution of the equation. Any point that falls on the line is a solution, okay? That's basically what we just checked. A point that falls here is still an ordered pair x and y, but it's not a solution because it's not on the line. You know, so let me see if I can find another example for you. Alright folks, I said I'm gonna give you an example. I'm going to give you a couple of examples to demonstrate the idea of linear equation in two variables, right? Look at this example here. So you go to Walmart or to King Super, you rent a carpet cleaner, right? And they said that you have to pay $30 flat fee, right? And then they say you have to also pay $10 each day you keep the carpet cleaner, and the day you picked up the carpet cleaner is counted as one day, even if you return it that day. So if you return it that day, you pay $30 plus $10, $40, right? Okay, so let's see what I did. Let's use the idea we solved a lot of problems. That's something like this in the one variable linear equation case. So I said let y be the total cost to rent the carpet cleaner. Let x be the number of days you keep it. Then you notice that y is equals to 10 times x plus 30. That's the general equation. You know what you will get. The y is the total cost and x is the number of days. Notice that that's a linear equation in two variables. The first variable is y, the second variable is x. So this is a perfect example of a linear equation in two variables. The equation is linear, it's a line, and it has two variables, you see. So given this, you can be asked a bunch of questions. Then you should be able to determine it. Let's say that now they said that, let's say Walmart say you kept the vacuum cleaner. You kept the vacuum cleaner, right? Not the vacuum cleaner, the carpet cleaner. Sorry, the carpet cleaner. You kept it. You kept it for. Oh Lord, what is that thing doing? You kept it for 6 days, right? Suppose you kept it for 6 days. Then the question is, what is the total cost? What would they charge you? What is the total cost? Total cost to you, okay? Okay, so how you solve that is, you see this is the total cost here, 10x plus 30, okay? And then here you said basically you're saying x is equals to 6 days. X equals to 6, then you evaluate that equation. You say y is equals to 10 times 6 plus 30, right? We've done stuff like this before. And then it's what is that? 60 plus 30. That's 90. Okay, that will give you 90. So basically that means you will pay $90. That's all that means. If you keep it for 6 days, you pay $90. And they see from based on what we did earlier, the example I did earlier, you have this ordered pair $6.90. That's what you have. Okay, so that's the if you put it in that equation, it will be true. The equation will be true. Okay. I mean, you can rearrange it. The best way to rearrange it is let me show you. See, you have 690, right? And then you given y equals to, what is that, 10x plus 30, right? You can rearrange it, say y minus 10x, all right, is equals to 30. Then you put 690 in there. If you put 690, would it be the other page 6 and 90? Would it be 30? Well, that's the question. If x is equals to 6, y is equals to 90, what happens? You get 90 minus 10 times 6. Okay. Will it be equal to 30? That's the question. So you said 90 minus 60. Is it equal to 30? Of course it is. 90 minus 60 is 30. So 30 is equals to 30. So it checked out. So this is true. That's how you do that. Supposing you kept it 10 days. You kept the vacuum cleaner 10 days, right? What is the total cost? What is the total cost? Okay, so you say y is equals to, what was that again? 10x plus 30, right? And then now you say x, you're giving x equals to 10. You solve the problem. Y equals to 10 times 10 plus 30. What do you get? You get 100 plus 30. You get $130. That's what you paid. Right? Yeah, that's what you paid. So the other pair is 10, 130. See? You see that, right? Put it in that equation, it will come out true. Now, supposing somebody can say, let's do C. Supposing, let's see, supposing you went back to Walmart, right? Went back to Walmart and you paid a total of $230, right? Then the question is how many days did you keep it? Did you keep it with you? Did you keep it in your house? Okay, that's the question. Now, so you have a total cost, total price you paid, right? Don't forget the equation is y equals to 10x plus 30, and you paid $230, right? So that means you went back there. Yeah, y is equals to 230, and then you have y equals to 10x plus 30. So now we're gonna solve to determine the number of days. You solve for x. You put the value of y, solve for x. So you have 230 is equals to 10x plus 30. Okay. So you rearrange stuff. Say 230 minus 30 is equals to 10x. You can move things around. You didn't hurt nothing. Move it like that. 230 over 30. Okay. and then 10x is equals to, what is that? Simplify the right hand side, you get 200, okay? And then that would be x is equals to 200 over 10. Just cross that, so x is equal to 20. So you kept it for 20 days, which means your ordered pair is 2230. So if you put this ordered pair in that equation, it will come out through. So please subscribe to my channel, like and share the video. If you have any question, leave it there, I will get to it. Let me see, I think I will wait. I was going to give you another example that has to do with temperature. You remember they convert temperature from Fahrenheit to Celsius, or from Celsius to Fahrenheit. So those two things, Fahrenheit and Celsius scale, they form a linear equation in two variables. I will talk about that. I think I will deal with that next time. We'll leave it here because I'm tired today. I'll see you. Thanks for coming. I'll see you in the next video.